Hello everyone, welcome to today's video. Before we proceed further, I would like to throw some light on the community that I've created. So in this community, I'm actually putting out off-campus opportunities related to placements and internships. So this is the community that I've created. So you can see that I've posted many opportunities, and yesterday itself I've posted more than 13 opportunities together. And the opportunities that I'm posting, that could be the official announcement from the company side or company web page or from the employees of that particular company. So I'm posting all those opportunities here, and actually I'm going through rigorous checking process before posting it out, because not all the opportunities that you see in various groups are completely reliable and trustworthy. But in my case, I'm making sure all those that I'm posting are completely reliable. Okay, so please feel free to share this community with your fellow peers and juniors, and also please do join this if you're actually looking out for some opportunities, or even if you got placed or doing an internship. It's better to know other opportunities as well. So the link to this particular community is given in the description below. Please go through it, and even share your comments and suggestions so that I'll improvise myself. So in this today's video, we'll be solving the problem longest subarray with sum divisible by k. This is a medium level question and it's the problem of the day on Geeks for Geeks. The company tags of this question are Microsoft and Snapdeal, and the topic tags are prefix sum, sliding window, arrays, hash, and so on. Okay. So let us go to the question now. Given an array ARR containing n integers and a positive integer k, find the length of the longest subarray with the sum of the elements divisible by the given value k. So the question is pretty straightforward. It is like you need to find the longest subarray such that the elements in that particular subarray, the sum of the elements in that particular subarray is exactly divisible by the given value k. This is the question that has been given. And these are some of the examples. Example 1, example 2. Proper examples have been given. We'll be using this to illustrate the concept. And the expected time complexity is O of n and the auxiliary space is O of n. So first I tried to figure out a solution with O of k auxiliary space, and it completely worked out. I thought that it is much more optimal, thinking that k value is less than n, but after seeing the constraints, k is actually much more than the value of n. Okay, so then I realized that it's better to confine to a solution which is actually having O of 1 auxiliary space. So this is the most optimal solution that anyone can come up with, as far as my knowledge is concerned. And so this is everything about the question. Now let us understand the question briefly. Okay, so this is the example 1 that has been given, and in this case the number of elements. Okay, so I'll just close this up. So the number of elements in this case is 6 and k value equal to 3. So array given as 2 7 6 1 4 5, and the output is equal to 4. So why is that output equal to 4? So you can actually see the explanation. The subarray is 7 6 1 4. So what is the sum of this sum of the elements in this particular subarray? That is 7 plus 6 plus 1 plus 4. That is actually equal to 18. Okay, and this 18 is exactly divisible by 3, isn't it? 18 is exactly divisible by 3, and this is the longest subarray that is possible. You can even take a subarray of length 5 and start doing it. So let us assume you're starting from here, subarray of length 5. This is what you want to get. This is the end point. So what is the sum? That sum is 26. That is not divisible by k. So you go and take with like starting from this point to this point. So what would be the sum that time? It is 23. That is also not divisible by 3. So the only subarray that is actually longest and also divisible by 3 is this particular point, 7614. And what is the sum? Is actually 18. That is the reason it is divisible by 3. And what is the length of this subarray? That is 4, because there are 4 elements. I hope you people understood that why is that output is actually equal to 4. Great. So this is the question that has been given. We'll be using example to demonstrate the case 2 that I'll explain later. So what is the naive approach to solve this? What is the brute force approach to solve this? So you might be thinking that yes, because there are n elements are there, so we'll be doing one thing. We'll be forming all the subarrays possible. Okay, we'll be trying to frame all the subarrays possible and take the sum of all those elements and check if that particular sum is divisible by k. Okay, and if a particular subarray is actually divisible by k, the sum of elements in a particular subarray is divisible by k, then we'll take that length into consideration and update our answer. Okay, let us assume we go with an initial variable as answer equal to 0, and we keep updating it as once in a while when we get that particular subarray sum to be divisible by k, and we'll be taking the longest length possible. This is the brute force, actual name brute force approach that you can come up with. But I hope we are all used to solve these type of problems where there is a question regarding finding a particular thing about a subarray. Okay, so contiguous subarray. So what is a subarray initially? It is a contiguous, segment of elements. So whenever there is something like contiguous segment of elements or subarray, the very first concept that you must actually try or try thinking of is the prefix sum. Okay, prefix sum array, prefix array. So all those things, that is the only concept that you need to use first. Okay, and if it is not working, then you need to go with some other concept. Okay, so the very first thing you need to think about is prefix array thing. Okay, so why prefix array? Because it is given in the question. It is like they're asking about the subarray. So when they're actually concerned about subarray, so we need to accumulate the result at any index I. So if I'm actually dealing with this particular array, I'll be accumulating the results at each and every I. Okay, at each and every index, and then I'll be trying out to find, so what could be the thing that they're asking, how to get to the actual output they're trying to they're actually asking us. So that is where you need to the first step that you need to do is use the concepts of prefix array. So how is this prefix array going to be useful here? So if you remember the question, like zero sum question, where they'll be asking you to find the length of the longest subarray where the sum of the elements is actually equal to 0. So how do you do that? The same thing, right? Same prefix array. So you'll be storing the sum of the elements till every index I. So here the sum is 2. At here this particular index, what is the sum? 9. At here the particular sum, what is the sum? 15. And till this point, what is the sum of the elements? 16. Till this point the sum of the elements is 20. Till this point the sum of the elements is 25. So if you find any sum repeating again, okay, let us assume this is also 15. Okay, let us assume here it is not 15, but let us assume it is 15. So if we see that 15 and 15 coming up once again, that means the elements in between, did not, their sum did not contribute anything to the original answer. That means the sum contribution here is 0. So that is how we are identifying that yes, there is a particular subarray involved here that is giving a 0 sum, isn't it? That is a very straightforward approach that we do. Similarly here as well, we'll implement a similar approach. So what are we going to do is, first we'll take this, before we proceed further as well, I hope that you people have a clear-cut definition about what is a remainder. Let us take some examples and first clear out the definition about the remainder. Okay, so taking the examples of positive numbers 9, 8, 7, 6. Okay, and you're trying to divide these numbers with k equal to 3. Let us assume this is the case. And there are some other set of numbers that are like -1, -2, -3, -4. And you're also trying to divide these numbers with k equal to 3. And now you're trying to come up with a conclusion like what would be the remainders. Okay, so let us put them on a number line first. Okay, let us put them on a number line and then evaluate this particular thing. So it is 0 here, and also I will take here the numbers to be 1, 2, 3, 4 itself, so that we not write the number line till the end. So it would be 1, 2, 3, 4, and this would be -1, -2, -3, -4. And now if you're trying to divide this particular numbers, these numbers with k equal to 3, what is the remainder in each case? Okay, when you're trying to divide 1 with 3, what is the remainder? It is +1. When you're trying to divide 2 with 3, what would be the remainder? It is +2. What is the remainder in this case? 0. What is the remainder in this case? +1. But what if you come to -1? What is the remainder in this case? It is -2. If you come to -2, what is the remainder in this case? -1. If you come to -3, what is the remainder in this case? 0. If you come to -4, what is the remainder in this case? -2. So what is the pattern that you're actually observing here? So in the negative world, in the world of negative numbers, any number, okay, any number, let us assume I'm standing on this particular number, it tries to go to its left to find the next possible exactly divisible number. Okay, so in this case you're trying to divide by k equal to 3. What are the negative numbers that are exactly divisible by 3? -3, -6, -10, all this stuff. So any negative number would like to go to that number. So that's the reason when you're actually on -1, you're trying to divide -1, the remainder in this case is -2. Okay, but in case of positive numbers, it will look on to its previous exactly divisible number. So if you're standing on 1 here, what is the previously exactly divisible number? It is 0. So it will try to go here. So that is the reason here remainder is 1. Okay, so I hope you people have a clear cut idea about this particular definition. So 1 modulo 3 is actually equal to 1, but whereas -1 modulo 3 is actually equal to 2. Okay, it's not -2, it's +2. So in the negative terms I have told you, but remainder can never be negative, it is +2. Okay, so +2 is what you need to do. Here the remainder is +2. I hope you have understood. When it is -1, the remainder is +2. When it is 1, the remainder is 1. Okay, so please have a clear cut definition about these things. I'm trying to put all the things in a grass root level so that there'll be no other doubts when you try to solve a similar set of problems. Okay, that is my main intuition. My intuition never confines to the problem of the day. You must learn something so that you'll be able to solve the other set of problems very easily. That is my ideology. Okay, so this is the thing. This is the clear cut definition of a reminder when it is a positive case and when it is a negative case. Okay, so let me erase all these things now. So what is the approach that we can actually solve here? So coming to these numbers, okay, coming to these numbers, as I've told you, at each and every index I accumulate the result. Okay, so what is the array that has been given? 2, 7, 6, 1, 4, 5. Now take the sum at each and every index. The sum here is 2. Till this index the sum is 9. Till this index the sum is 15. Till this index the sum is 16. Till this index the sum is 20. Till this index the sum is 25. Okay, now check the remainder. In this case, the remainder is when you're actually dividing by k equal to 3. Okay, the remainder is what is the remainder in this case? It is actually 2, because what is the previous number to 2? 0. So it will try to come to 0. So 2 units away. 2 is 2 units away from 0. That's the reason remainder is 2. And what about 9? It is 0. What about 15? It is 0. What about 16? It is 1, because it will try to come to the previous exactly divisible. What is previously exactly divisible with respect to 16? 15. So how much units is 15 far away from 16? 1 unit. So that's the reason it is the remainder. Coming to 20, how much it is? 2, because previously exactly divisible number is 18, right? So it is 2 units far. Coming to 25, it is 1, right? So this is the remainder. Now can you observe some numbers being repeated? 2 and 2 is being repeated again. Okay, 2 in 2 is being repeated again. How is that so possible? What can you infer from that? What can you understand from that pattern? So take a very naive example. Okay, take very simple example. Have given you number 6. Okay, and I've asked you to divide it by 7. What would be the remainder in this case? The remainder is equal to 6, right? And now I've given you another number, that is 20. Now I've asked you to divide by 7. Okay, so what is the remainder in this case? Again it is 6, isn't it? The remainder is coming up to be the same number. So what did you add to 6 to get 20? That is 14, which is exactly divisible by 7. Okay, it is exactly divisible by 7. So if you're trying to add some numbers to a result, I mean to a present number, some number, okay, some quantity, if you're trying to add to a present number, and the resultant is also giving you the same remainder as the initial number, that means you have added such a number that is exactly divisible by the number that you're dealing with. In this case it is 7. I hope you people have understood. So 6 to 6 I've added 14. That's the reason I've got 20, and I've got the same remainder. Okay, I've got the same remainder. And what can I understand from this? Okay, that means I've added some number to 6 that is exactly divisible by 7. That is the reason I'm getting a same remainder. So this is basically cyclicity, isn't it? The cyclicity. What is the range of cyclicity of 7? It is from 0 to 6. So numbers will only be in the world of 7. The numbers will only lie between 0 to 6. Okay, so in 6, in the world of 7, 6 is 6, and also 20 is also 6. Okay, 20 is also 6. Why? Because when you divide 20 by 7, you'll be getting a remainder as equal to 6. This is basically cyclicity. This is cyclicity of numbers. So you have added such a quantity to 6 such that the resultant number is also giving you a remainder that is actually equal to 6. That means there is some number that you have added that is exactly divisible by 7. Okay, the same thing that is also happening here. Okay, the same thing that is also happening here. So k equal to 3 in this case. Here the sum is 2, here the sum is 20. So in both the cases the remainder is actually equal to 2. That means you have added some result to this, that is exactly divisible by k. And what is that result? That result is 18, isn't it? 2 here in this case it's 20, here it is 2. How much did you add? 18. So if you take the sum also, you'll be getting that same only. 7 plus 6, 13, plus 1, 14, plus 4, 18. The exact number, isn't it? 18. It is divisible by 3. That is the reason you are getting same remainder in both the cases. I hope you people have understood this small tiny concept. Okay, now you are not concerned with what is the result that you have added. You are only concerned with what is the length of the subarray. So how do you take the length of the subarray? So you just take the same thing. So initially 2 when it actually appeared at index equal to 0. Now when it is actually appearing at index equal to 0, 1, 2, 3, 4, 4. So what is the length of the subarray that it is actually contributing to this sum? 4 minus 1, that's actually equal to, 4 minus 0, that's actually equal to 4. There are 4 elements. What are those 4 elements? These are the 4: 9, 15, 16, 20. Not 9, 15, 16, 20. These are the elements. 7, 6, 1, 4. These are the elements. These are the subarray. This is the subarray that is actually having a sum divisible by 3, exactly divisible by 3. I hope you people have understood. Okay, now let us assume we'll extend this something like we'll put another elements here, put extend array till this point, and we'll be getting again here. And now again you have got 2 here. Okay, again you have got 2 here. That means now you can take this whole thing, isn't it? This whole thing. That is the reason what you'll do is initial occurrence you will store. Okay, initial occurrence you will store, and find afterwards whatever occurrence will be coming, you'll be taking the subtraction of that particular index till the initially stored index, so that you'll be taking the longest subarray. So in this case, will you consider this particular subarray or this particular subarray? The longest one you'll consider, isn't it? So that's the reason initial one you store, initial one you will be storing, the final one you will keep it going on, you will not be storing anywhere. If you will be getting 2 here, again you will be subtracting this index from this index, and then you'll be updating that, because now you have got a bigger array, you have got a bigger subarray. Okay, that is the thing. I hope you people have understood this. Very easiest thing, to be honest. There's nothing like confuse or something. Okay, now this is the case when it's positive. Okay, everything is going fine. Now let us assume now you have got in negative numbers. Okay, you have got in negative numbers. Now here the array that has been given is -2, 2, -5, 12, -11, -1, 7. Again do the same thing, accumulate the results. Okay, so what is the sum till this point? -2. What is the sum till this point? 0. What is the sum till this point? -7. What is the sum till this point? -7 plus 12, that is 5. Till this point, -6. Till this point it's -7. Till this point it is 0, right? So you have got a sum that is still 0. So I think I did a mistake. -2, 2, it's fine. 0 -5, 7. Okay. Okay, so see, this is the thing that I've done mistake. Okay, I was actually assuming. So -5, this is 7. Okay, and this is -4, and this is -5, and this is 2, right? That is the thing. Okay, now it is fine. Now it is completely fine. So what is the thing that you can understand from this particular scenario? So you have got these things. Now try to divide by 3. Okay, now here also k is actually equal to 3. What is the remainder when you divide this by 3? So come to the negative world. Okay, come to the world of negative numbers. Now what would be the remainder when you divide -2 with 3? It will go to the next occurrence, means the number that is going to come. So here what is the exact number, the number that is exactly divisible by 3 after -2? That is -3. So how much distance is there between them? 1. So put that one here. Okay, I hope it's clear cut for you people. So I'll just erase this thing. So -2, in this case of -2, its remainder is actually equal to 1. In the case of 0, what is the remainder? 0 only. In the case of -1, what is the remainder? Again, sorry, do not put negative, it is 1. Okay, and in the case of 7, what is the remainder? It is 1. In the case of -4, what is the remainder? 2. In the case of -5, what is the remainder? 1. In the case of 2, what is the remainder? 2. Okay, so I hope you are able to figure it out. How are we actually doing it, right? That is pretty clear. Now see the same logic again. You can see 1 and 1 is being repeated here. So 1 is repeated here as well. But will you take these two subarrays? No, because compared to these two lengths, this length is much more bigger. So you'll be taking this into consideration. What is the length? That in this case 5 minus or equal to 5. And what are the elements that are being contributed? 2, -5, 12, -11, 1. So the same remainder is appearing again. Okay, the same remainder is appearing again. That means you have added some quantity that is exactly divisible by 3. And what is that quantity? If you actually add them up, 2 minus 5, that is actually equal to -3, and plus 12, that is actually equal to 9, -11, that is actually equal to -2, and then -2 -1, that's actually equal to -3. And yes, -3 is exactly divisible by 3. That is the reason you are getting the same remainder 1 and 1 once again. Okay, the same logic in the case of negative numbers as well. You must be clear, you must be taking a precaution while actually taking the remainder in case of negative numbers. Okay, so how do you do it? So that is the reason I will show you that what thing that I've implemented there to get the correct reminders in this case. Okay, so I hope this is the logic. I have completed the explaining the whole logic here. There is no more things to be added. So you'll be storing this initial index, and whenever you'll be getting the same index, take that particular difference. But in case if you are getting a 0 till this point, okay, till this point we have got a 0 result. That means this is also divisible, isn't it? The 0 sum is divisible by any number. So in this case also take that length also into consideration, because if in case instead of 2 here you have got a 0, okay, that means the whole sub array sum is actually equal to 0. That means the total array can be considered to be divisible by k, because 0 sum is divisible by k, isn't it? So you'll be considering that also. So whenever you'll be getting that particular accumulation to be 0, take that length as well. Subtract that particular index minus 0 as well. Okay, that is also very important. Okay, now going through this code. So this is the first thing. Firstly, int answer to be equal to 0. This is where the actual answer is stored. Okay, and now taking an unordered map to store the things, and this is the reminder. Okay, so reminder plus array of I. This is where we are taking the precaution. Okay, precaution to make sure to deal with negative numbers. Okay, deal with negative numbers. I've also taken a custom input like this thing. So here you can see 7 minus 1 2 minus 2 minus 9 0 minus 4 minus 3 0 9 minus 9. These are the elements of a particular array. Okay, now try doing it manually using a pen and paper. You'll observe that if you do not put a plus k here, you'll be getting different reminders. You'll be getting negative reminders. That is not correct. Negative reminders are not defined. Always the reminders must be positive. That is the reason we are adding a k, so that the cyclicity is maintained. Okay, so use a pen and paper to solve this. What I'm actually trying to explain you'll be getting a better understanding if you try doing it manually on a pen using a pen and paper. Okay, then you'll be understanding it. So that's the reason we are adding plus k. And suppose if you're so far the reminder is actually 0, that is what we are taking, right? Every point we are adding up and we are taking the reminder. So if your reminder is turning up to be 0, that means we have come to that point where the total sum is actually divisible by that particular k. So you can take that particular length. So I plus 1. So I plus 1, I index denotes that particular index. So add plus 1, so that number of elements will be counted. Else if that same reminder you have found once again, okay, you have found that reminder once again. So in this case, this is like first time you are encountering that particular reminder, so store that initial index. Else you have already found that reminder back like before, then you can just take that index minus that index that you have stored in MP of reminder. Okay, so the same thing that I have explained here, I have put it in the code. Okay, so finally return answer, because everywhere we are taking the maximum possible length, so finally we'll be returning that particular answer. So that's it guys, very easy. So this is the point where it is bit tricky to make sure the reminder does not go into negative numbers. We are only storing the positive numbers, and this is where like reminder equal to 0, that's pretty common sense. If it is 0, that means the whole exact thing is divisible by k, so take that I plus 1, so that exact number of elements are covered. If it is like first time that you are visiting, store that in index. Else if it's a second time or third time, make sure you are subtracting it and taking the maximum length out of the answer. Okay, so that's it. I hope you people have understood. So if there are any doubts, please feel free to comment in the comment section, and also put the codes in C++, Java, Python, so you can even go through them for better reference. So thank you guys for watching this video. Stay tuned.